Good evening, students. I am Professor C.P. Akilan, founder and director of Marvel Educare. This is my 25th year in mathematics coaching. To celebrate this, we launched one Marvel Digital Studio at KK Nagar branch. Through this branch, today we have a live session for trigonometric identities. Next month, first week, we are planning to launch digital courses through our website. For NEET, JEE Main, JEE Advanced, CBSE 9th to 12th, all subject mathematics, physics, chemistry, biology. Every week you have one free live classes from our studio. So definitely we will send the link before 1 hour. In this session, I am going to take trigonometric identities, one of the very important exercise and very big exercise in 10th standard CBSE syllabus. First, I will prove all the three identities in that exercise. If you know the proof of each identity, you can solve any type of trigonometric identities problem. So first we will go through that proof of first identity. Prove geometrically sin square A plus cos square A equal to 1. Sin square A plus cos square A equal to 1. Draw one right triangle, the right angle at B based on measure angle A by Pythagoras theorem, AB square plus BC square equal to AC square. Dividing by A square, this is very important. Dividing both sides by AC square, AB square by AC square, BC square by AC square and AC square by AC square, and this becomes 1. AB by AC, AB by AC. Adjacent side by hypotenuse is cos theta, that is cos square A, and BC by AC. Opposite side by, this is opposite side, this is adjacent side, and this is hypotenuse. Okay, opposite side by hypotenuse is sin square A, cos square A plus sin square A equal to 1. This is a proof of first identity. Using this identity, we have two important results. One is sin square A equal to 1 minus cos square A, or cos square A equal to 1 minus sin square A. Don't forget, divide by AC square for the first identity. Second identity, prove geometrically that 1 plus tan square A equal to secant square A. 1 plus tan square A equal to secant square A. Same right angle at B by Pythagoras theorem, AB square plus BC square equal to AC square. Here divide both sides by AB square. In the previous identity, what is division? Division by AC square, but here it is AB square. So AB square by AB square, BC square by AB square and AC square by AB square. 1 plus BC square, BC by AB the whole square equal to AC by AB. BC by AB, BC by opposite side, adjacent side and the hypotenuse. So BC by AB is nothing but tan theta, that is tan A, 1 plus tan square A equal to AC by AB, hypotenuse by adjacent side, that is secant A, secant square A. 1 plus tan square A equal to secant square A. So we have two important results. Secant square A minus tan square A equal to 1, or tan square A equal to secant square A minus 1. But don't forget, here you have to divide by AB square. For every identity you have one condition, divide by which side, but based on the value of, because tan A is sin by cos, secant is 1 by cos. For cos theta, always use divide by AB. For cos theta, divide always by AB. And the third proof, prove geometrically 1 plus cot square A equal to cosecant square A in right triangle ABC, right angle at B by Pythagoras theorem, AB square plus BC square equal to AC square, divide by BC square. The first case we divided by AC square, second case we divided by AB square, in third case for third identity divided by dividing both sides by BC square. So AB square by BC square, BC square by BC square equal to AC square by AC square. AB square by BC square is AB by BC the whole square plus 1 equal to AC by BC. AB by BC, AB by BC, this is adjacent side and this is opposite side and this is hypotenuse. Hypotenuse. So AB by BC is cot square A plus 1 equal to AC by BC, hypotenuse by opposite, that is cosecant A, cosecant square A. So the third identity is 1 plus cot square A equal to cosecant square A. Now two important results from this identity, cosecant square A minus cot square A equal to 1 or cot square A equal to cosecant square A minus 1. So far we proved three identities. The first identity is, I will revise the identity along with one condition. First identity, sin square A plus cos square A equal to 1. Second identity, 1 plus tan square A equal to secant square A. And the third identity, yes, 1 plus cot square A equal to cosecant square A. Here we have an important condition for A. For the first identity, the range of A greater than or equal to 0, less than or equal to 90. For the second case, greater than or equal to A, strictly less than 90. Third case, greater than or equal to 0, strictly less than 90. Here 90 is included here because sin 90, cos 90, sin 90 and cos 90 possible, sin 90 is 1 and cos 90 is 0. Here 90 degree is not included here. The reason is tan 90, second case 90 degree is not included. Reason is tan 90, what is tan 90? Yes, it is not defined. Tan 90 is not defined and hence it is not included. Similarly in third identity also 90 degree is not included. This is 90 degree. Third identity, because cot A, tan cot A, cot 90 is 0 and cosecant 90 is not defined and hence yes, and hence it is not included. 1 plus cot square A equal to cosecant square A. Okay, next. So in this identities exercise, you have 15 types of problems. If you know the classification of problems, what is the type of that problem and how to solve that problem, then you can easily solve any type of trigonometric identity. I will explain 5 types in this screen, 3 identities proof and all conversion. Today already I proved 3 identities proof and all conversions. Next problem I will explain and another 5 types. There are 15 types of problems in this exercise, but in NCERT book you have only 7 or 8 types only, but in R.D. Sharma it covers all the 15 types problem is there and more than 200 sums are there in R.D. Sharma exercise and solved example. In our digital course, we provide all the 15 identities with a lot of examples, minimum 3 problems, examples to maximum 20 plus, depends upon the content of the type. In our from October first week onwards, our digital course available through our website. We will definitely announce that with grand manner. Next, Type 2. Write all other trigonometric ratios of measure angle A in terms of secant A. In terms of secant A. This is right triangle ABC 90 degree. This is opposite side, adjacent side and hypotenuse. In terms of secant A, first sin square A equal to 1 minus cos square A, from the identity sin square A plus cos square A equal to 1. Now first identity in terms of secant, first convert sin in terms of cos, okay, cos in terms of secant. What is sin A equal to? From this, what is sin A equal to? Root of 1 minus cos square A. We can convert in terms of, here you can convert in terms of root of 1 minus 1 by I think here 1 minus 1 by secant square A. This is not there, typing error. Now if you cross multiply secant square A minus 1 by secant square A, secant square A minus 1 is, yes, everything in terms of secant A. No need to convert in terms of tan square A because question is in terms of secant A. First sin in terms of cos, cos in terms of secant. Second one cos in terms of secant, directly you can write because both are reciprocal to each other and hence you can directly convert. This is by using which concept? Reciprocal concept. And this is tan square A equal to secant square A minus 1 using the identity. Using identity, then tan A equal to, this is first, second, third function. Tan A equal to root of secant square A minus 1, cot A, reciprocal of this. Cot A equal to 1 by tan A, reciprocal of this. And this is fourth one. Next fifth one, cosecant A is reciprocal of sin A and reciprocal of the first expression secant A by secant square A minus 1. One of the very important 4-mark question in this exercise, one function in terms of remaining 5 functions. One function in terms of remaining 5 functions. This is type 2 in my 15 types of problems. Write all other 5 trigonometric functions in terms of secant. First I will revise again, sin in terms of cos, cos in terms of secant, okay. Then cos in reciprocal function, cos in terms of secant using reciprocal identity, tan in terms of secant using the direct identity, and cot is reciprocal of tan, cosecant is reciprocal of sin, okay. Type 2 over. Next type 3, one of the very important type, method of cross multiplication. Method of cross multiplication, prove that cos A by 1 plus sin A plus 1 plus sin A by cos A equal to 2 secant A, both are reciprocal to each other. So LHS equal to, write the expression again, cross multiplying cos A into cos A, cos square A plus 1 plus sin A into 1 plus sin A, 1 plus sin A the whole square by 1 plus sin A into cos A, 1 plus sin A into cos A. Cos square A, if you expand A plus B whole square formula, A square plus B square plus 2AB, cos square A plus 1 plus sin square A plus 2 sin A by denominator. Very important, don't multiply the denominator because already it is in factorized form. Now cos square A plus sin square A using the first identity, cos square A plus sin square A is 1 and one more 1 is there, plus 2 sin A. So 1 plus 1 is 2, 2 plus 2 sin A, taking out 2 outside, 2 into 1 plus sin A. Now cancelling the common factors, 2 by cos A that is nothing but 1 by cos A is secant A, reciprocal of cos is secant A, 2 secant A, that is the RHS, so which is equal to this. So this is third type under method of cross multiplication. Just write the expression again, then apply the cross multiplication using the identity a plus b whole square equal to a square plus b square plus 2ab. Type 4. One of the very important and very tough type, replace 1 by identities, replace 1 by identity. Previous one is method of cross multiplication, now this is replace 1 by identity. Which identity you can apply? Very simple technique based on the RHS. So the given expression is prove that cos A minus sin A plus 1 by cos A plus sin A minus 1 equal to cosecant A plus cot A. If you simplify this, this is 1 by sin plus cos by sin, and hence divide numerator and denominator by sin A. So how to select this function? Based on the value of the denominator of RHS. Okay. Therefore, write LHS cos A minus sin A plus 1 by cos A plus sin A minus 1. Divide numerator and denominator by sin A. This becomes cos A by sin A minus sin A by sin A, 1 by sin A. This is numerator. And denominator is cos A by sin A plus sin A by sin A minus 1 by sin A. The numerator becomes cos by sin is cot A, sin A gets cancelled, 1 by sin A is cosecant A, and denominator cot A, sin A gets cancelled, plus 1 minus 1 by sin A. Rewriting the numerator cot A plus cosecant A minus 1. So this is very important. This itself one 3 mark question, but this is tough 4 mark question. Okay, so at this stage, replace this 1 by the corresponding identity. So this is type 4. Replace 1 by corresponding identity. Next. So what is the corresponding identity? So how to select the identity? Very simple. Based on the function cot A and cosecant A. So here you have to replace 1 in the numerator by cosecant square A minus cot square A. Cosecant square A minus cot square A. So replace 1 by cosecant square A minus cot square A. Very important, you can replace only the numerator, not the denominator. Fix the whole denominator as it is. Therefore the denominator becomes cot A plus 1 minus cosecant A as it is. Factorize this expression, cosecant square A minus cot square A. So if you factorize cosecant A plus cot A into cosecant A minus cot A, and taking out the common factor, this is common expression in the numerator, cot A plus cosecant A into 1 minus cosecant A minus cot A. Removing the bracket, 1 minus cosecant A minus into minus plus cot A. So you can cancel this factor and denominator. The final expression is cot A plus cosecant A. Final answer is cot A plus cosecant A. That is RHS. This is type. So 1, 2, 3. This is type 1. Question number 4 type 2. Question number 5 type 3. And type 4 question number 6. Type 4 question number 6. Next. Type 5. Multiply and divide by conjugate of denominator. How to decide the conjugate of denominator? Very simple. Whenever the denominator expression has identities with the negative sign, for example secant square A So whenever the denominator expression has identities with plus or minus sign, for example 1 minus sin square a, 1 plus sin square a, 1 minus sin square a, 1 minus cos square a, secant square a minus tan square a, cosecant square a minus cot square a, secant square a minus 1 and cosecant square a minus 1. For all the 6 type of denominator, we can apply the concept of multiply and divide by conjugate of denominator. So first write the LHS equal to root of 1 plus sin a by 1 minus sin a. Very important, multiply and divide only inside the square root. So what is the conjugate of 1 minus sin a? Conjugate of 1 minus sin a is 1 plus sin a by 1 plus sin a. 1 plus sin a by 1 plus sin a. The numerator becomes, this is one expression, 1 plus sin a the whole square, and denominator 1 minus sin a into 1 plus sin a, that is 1 minus sin square a, that is cos square a. Both are even powers, second degree, so we can apply the square root concept. 1 plus sin a the whole square is 1 plus sin a, and square root of cos square a is cos a. Splitting into two terms, 1 by cos a plus sin a by cos a. 1 by cos a is secant a and sin a by cos a tan a. Sin a by cos a tan a. This is type 5 method of multiply and divide by conjugate of denominator. Very important, don't forget here multiply everything inside the square root. Inside the square root, not outside. This square root removes only at this stage. At this stage, the power of both numerator and denominators are even power, that is power 2. Okay. Next. Type 6. Whenever the expression has, question has 3 expressions. Last 7 sums you have LHS and RHS, but here we have 3 expressions. Whenever if problem has 3 expressions, this is a method of working rule. Take LHS. If you compare first, second and third, this is simple one. So prove first to third and second to third, then first equal to second equal to third. Okay. Now LHS equal to 1 plus tan square a by 1 plus cot square a. The basic method for simplification of any trigonometric identity, this is one more type, basic function. What are the basic function in trigonometry? Only 2 functions, sin a and cos a. These 2 are the basic functions, sin a and cos a. So replace tan a by sin a by cos a, sin square a by cos square a and cos square a by sin square a. If you cross multiply, cos square a plus sin square a by cos square a and sin square a plus cos square a by this, both numerators gets cancelled. Both numerators gets cancelled, and hence the numerator becomes 1 by cos square a, 1 by sin square a. So what is 1 by cos square a? 1 by cos square a is, so you can replace, we can write in the reciprocal form, 1 by cos square a into sin square a by 1. So sin square a by cos square a, that is tan square a. The first to third proved. First to third proved. Next, take middle expression. Same concept, 1 minus tan square a by 1 minus cot square a, replaced by the basic function sin a and cos a, sin a by cos a. Sorry, some typing error is there. Next, conditional identity type 7. One of the tough 4 mark question. Cot a plus tan a equal to x and secant a minus secant theta minus cot theta plus tan theta equal to x and secant theta minus cot theta equal to y. Prove that this expression. The given expression, first simplify the given expression into simplest form. Simplest form is nothing but product of the functions. So x equal to cot theta plus tan theta, basic function cos by sin plus sin theta by cos theta. If you cross multiply, cos square theta plus sin square theta by sin theta cos theta. So this is the simplest form of x. Next y, secant theta minus cos theta. So secant theta is 1 by cos theta, and cos theta as it is, if you cross multiply, 1 minus cos square theta by cos theta, which is equal to sin square theta by cos square theta. Next, find the value of this expression, that is x square y, and this expression xy square. X square y is square of this into y. What is square of that? 1 by sin a sin square theta into cos square theta into y. What is y? Y equal to sin square by cos square. So these two gets cancelled. 1 by cos cube a, 1 by cos cube theta. Next, xy square, 1 by sin theta cos theta into y square, square of this, sin power 4 by cos square. Sin cancel, and hence this is sin cube by cos cube, sin cube by cos cube. Now writing substituting these two expression in this LHS, x square y whole power 2 by 3, x square means 1 by cos cube whole power 2 by 3, and minus xy square whole power 2 by 3, sin cube by cos cube whole power 2 by 3, this is 1 by cos, 3 cancel. So 1 by cos theta the whole square, and 3 cancel, sin theta by cos theta the whole square, which is equal to, both the denominators are same, 1 by cos square theta minus sin square theta by cos square theta. 1 minus sin square theta by cos square theta, 1 minus sin square is what? Cos square by cos square 1. So this is 7th type. The remaining 8 types we completely discussed in our digital course, and each type for conditional identity we discussed more than 40 sums in our digital course. Next month first week the course will be available. Also we will upload another few videos, free videos in our Marvel Educare YouTube channel. Okay, so every week we will send free videos as well as concept based videos also. Thank you.